Hello everyone, and welcome back to the show. It's your host, ichino-ani, here to bring you some exciting news from the world of computers. Today is September 22nd and lovely Monday. And oh boy, do we have a super interesting paper that just popped up in the archives. Let's all take a look together, shall we? The title is Generalizable Geometric Image Caption Synthesis. Yeah, that's a mouthful, isn't it? It's a brand new paper from some very smart people at places like the University of Illinois, NVIDIA. So let's break it down. Just like LAM class. Imagine you have a super smart robot friend, but whenever you show it a math problem with shapes, like a geometry question, it gets all confused. It's the big problem this paper is trying to solve. These amazing AI models, which can look at pictures and read text, were actually not very good at geometry. And why is that? Well, it's because the books they learn from aren't very good. The pictures and the words in their geometry textbooks don't always match up perfectly. It's like if a book said, these 10 lines are the same length, but in the picture, one line looks much longer than the other. It would be super confusing for anyone trying to learn, right? That's what's happening to our AI friends. So what did these clever researchers do? They decided to create a brand new, super duper textbook for the AI. They call it the GENERALIZABLE Dataset. It has 10,000 pictures of geometry problems with descriptions. But here's the magic part. In their dataset, every single picture perfectly matches its description. If the text says an angle is 90 degrees, the picture has a little square to show it's a right angle. If two lines are equal, they have the same little tick marks on them. Just like in our math books. We made this dataset using a really cool method. It's a bit like training a puppy. First they have an AI try to write a description for a geometry picture. Then, another AI, the math solver, tries to solve a math problem using only that description. If the description is good and helps solve the problem, the first AI gets a reward like a little treat. If the description is confusing, it doesn't get a reward, and it has to try again to write a better one. They keep doing this over and over, and the AI gets better and better at writing perfect descriptions. Isn't that neat? Now you might be thinking, that's cool for geometry, but how does this help me? That's a great question. This research has some amazing applications in our everyday lives. Let's think of 3 examples. First, imagine a homework helper app on your phone. You could take a picture of your tricky geometry homework, and the AI wouldn't just spit out the answer, because it truly understands the picture. It could guide you step by step. It could say, this triangle here, because these 2 sides are equal. You know, these 2 angles must also be equal. It would make learning math so much more interactive and fun. Second, let's think about engineers and architects. They work with very complicated drawings called blueprints. An AI trained with this new method could look at a blueprint for a new building or a car engine and automatically create a detailed report about it. It could even help catch mistakes, like it could warn an engineer, and this part in the drawing doesn't look like it will fit with the other parts. And for our third example, let's think about self-driving cars. A self-driving car's brain needs to be an expert at geometry to understand the world. It has to see the parallel lines of a lane, understand an angle of a turn, and figure out the distance between itself and other cars. By making AI better at basic geometric reasoning, we're building a stronger foundation for these cars to navigate our roads safely. So, how does this new method compare to older ones? While other databases for training AI and geometry were more focused on quantity, they had lots and lots of pictures, but the quality wasn't always great. The pictures and text were sometimes mismatched. This new paper takes a different approach. It focuses on quality. They made sure every single one of their 10,000 examples was perfect, and it worked. The AI they trained on their special dataset not only got better at geometry, but it also improved on other types of math problems, and even on questions about art and engineering. That's a really big deal. It means the AI didn't just memorize answers. It learned the fundamental skill of reasoning about shapes and space, that it could use that skill to solve new and different problems. So to wrap it all up, this paper shows us that by carefully teaching AI the basics, just like we learn the alphabet, we can help it develop amazing reasoning skills that can be used everywhere. It's a wonderful step forward in making AI smarter and more helpful for all of us. That's all the time we have for today, everyone. Thanks for tuning in, and keep on being curious. This is ichino-ani, signing off. Bye-bye.